Properly using slicer software is one of the most critical aspects of creating a successful 3D print. Slicer software is what generates the instructions for the 3D printer to create your object. It begins by taking your shape and slicing it into layers. It then generates instructions for the printer to create each of these layers, which it successively builds up. We use the slicer software Cura. It is available on our computers at the Makerspace. The slicer software has certain parameters that need to be filled in based on the printer you are using and the print quality you desire. First, you need to specify which printer you are using. Notice that the work area changes depending on the printer you choose. This represents the size of the print bed for your selected printer. You can open your STL file here, and it will appear on the print bed. Right-clicking an object allows you to duplicate it or delete it. You can add as many objects as will fit in the build volume, designated by this rectangular prism. With an object selected, you can change its position, orientation, and scale. Next, you need to select the type of material and print core you will be using. Each printer is labeled with the material and print core it currently has equipped. In this case, we are using PLA with a 0.4 mm nozzle. Extruder 1 is the default. If you are not using multiple filament types in a single print, then you do not need to specify the second extruder. You can leave it unenabled. To the right are further settings that we can specify for our print. Some printers come with print profiles to help your print match its intended use. For most prints, the default profile will be fine. Visual prints will have a better surface finish. Engineering prints will have higher dimensional accuracy. And draft prints will have lower quality but print faster. These profiles are not available for all of the printers we have in the Makerspace. The resolution is the layer height. Remember that the printer will build up our object layer by layer. A larger layer height will print faster but sacrifice some accuracy in the piece. Infill refers to the internal structure of your print. The outside, which makes up the shape that you can see, is called the shell. Infill helps support the structure of the shell. Increasing infill percentage uses more material and will increase print time, but also increases the strength of the part. For most parts, 10 to 30% is fine. For structural parts, 50 to 80% is fine. You will rarely need 100% infill. Gradual infill is mostly used for decorative parts to reduce the material wasted. You can choose to add support material for overhanging areas of your print. An overhanging structure is one that sticks out without any printed material below it. The printer needs a surface to extrude material onto. Overhangs with a significant angle will cause the print to fail as the filament falls down unsupported. But the support setting in the slicer will print material below the overhanging structure to support it at the appropriate layer. This support structure peels away when the print is finished, leaving only your desired part. Note that support structures will increase print time. Usually, you will want to orient your model in such a way to reduce the amount of overhanging structures that need support. This will reduce the print time and make your print more likely to succeed. Finally, you can add an adhesion layer to your print. This is a footprint around your object that will help it stick to the bed. Remember that the print material will contract as it cools, which could cause it to break away from the print bed or warp. This can lead to further issues like spaghetti prints. This is especially true for small or thin objects. Adhesion layers are generally not necessary for parts with large flat surfaces contacting the print bed. Once you have input the proper parameters, press the Slice button. This will generate the instructions for the printer and show an estimated print time. If you are unhappy with the print time, you can modify settings and slice it again. You can load the slicer instructions onto a USB drive to transfer them to the 3D printer. Each printer already has its own USB that you can use. See our next video for how to use this file on the USB to begin a print.